Hi, I'm Nick Anderson, product manager for Creative Space, and we are going to have Steve Grappone, who is our director of storage technology, go through pretty much kind of the history, past, present, future of storage. And we'll have Bill Webb from Mellanox talk about what they're doing with the different NIC technology with Ethernet, and then I'll go through what that means for creativity and what we can do with this technology.
Thanks, Nick. I'm Steve. I'm work for Digital Glue, and I've been doing storage for a little over 10 years now. And over that 10 years, I've learned a few things about storage. When I first started, we used to have the Apple X-Rays, and they used to have PATA drives. They weren't very fast. So then we moved up and we got SATA drives, which were much quicker, but still wasn't quite where we needed to be. So we went faster and we went up to SAS drives, and this got us a lot closer to where we needed to be, and it also gave us enough space. But when we needed faster IOPS, we needed faster drives, SSD and NVMe wasn't out yet, so we had to use fiber channel drives, beta drives. And then later we were blessed with SSDs and NVMEs, which we'll dig into much deeper here in a minute. So to backtrack a little bit, in the 90s, Lockheed Martin was assigned to bring video to the desktop. And I actually got to have a conversation with the guy that led the team into developing this. And he got up there and he goes, so how are we going to get this video to the desktop? Because right now, network's only 10/100, and it's just not fast enough. We can't get there with that kind of speed. So one guy said, well, we can use fiber channel, which was great, but what are you going to send over fiber channel? We don't really know much about that technology yet. So we went with sending the SCSI commands over fiber channel. So that meant that all the machines, so it would be connected directly to a hard drive with a 1 gigabit fiber channel connection. So the goal was to saturate that 1 gigabit line, and they were very successful in doing that. And then he goes, you know, after we sold it and things were gone, I started thinking that we weren't really planning on people writing content and then deleting it, and then writing content again and then deleting it. So what happened is it would call all these extents, and it little files that went to the SAM. It became almost useless because it was too slow. We couldn't do IOPS. It was more streaming based. So, but with all that stuff in the 90s, Lockheed Martin sold it to CentraVision, then sold it to Mountain Gate, that sold it to ADIC, that StorNext was born. So in around 2007, a lot of people were getting rid of their decks and moving to more of a file-based workflow. So they had a decision. They could either go with the NAS or they could go with the SAN. So if they went with the NAS, they were kind of locked in at 1 gigabit network, which wasn't fast enough for the video. But if they went with the SAN, they could all work together, and they could get 400 megs with one 4 gigabit fiber channel. And if they wanted to, they could even double it and put 2 4 gigabit and get close to 800 megabytes, which was great, but there were some disadvantages. If one of the little Gibbix went out, you'd lose the entire chassis and the SAN was down. If one of these failure points went to go down, then it was unusable, and it would fragment. So when you wanted to do DPX and have a lot of IOPS, it just wouldn't work. So in 2009, SSDs came out, and that made us all feel a lot better because now we could play back those DPX frames, those lots of IOPS files, and we weren't being restricted by the spinning platters spinning around. So we could get our IOPS. But the problem is that we were connecting it on a 6 gigabit line, which meant that we were capped off at 550 megs a second. And if you had the money and you had 12 gigabit SAS, well, it got you a little bit closer. It got you to 1100. But for OpenEXR, I know it takes about 1600 megs bit rate, so you wouldn't have it already off of that. So now we're going to I think we're going to start using a lot more NVMe in media and entertainment because it can deliver 3000 megs a second, and it is about 2 terabytes in size, and it is about, the laser doesn't work on this, but it is about the size of a stick of gum.
Steve, maybe explain what an IOPS is. I don't know if everybody knows.
No one knows what an IOP
Okay,
is?
got it. I'm sorry.
So an IOP is an input-output per second, meaning how fast can I write a file and delete it in 1 second. And that unit there that we have can do about 10,000 of those operations, which is pretty unheard of. 10 million, I'm sorry. Yeah, 10 million. Normally people brag about 250,000, and we're at 10 million, so that it's pretty nice. So will it be the future? Well, I think it already is. It's starting to come standard in PCs. We have it standard in our server, and when you actually look at the price per gig, it's actually less expensive than it is with a traditional SATA drive, and you're not capped at that 6 gigabit connection. So here are some numbers, and it kind of gives you an idea. If we look at the top left one, it takes 250 SATA drives to get to that 100 gigabit network saturation. Where over here with the NVMe, it only takes 4. And it's going to deliver the IOPS that all those SATA drives can't get, because if the SATA drive loses it, it has to spin around again and hope that it gets it. And I've never seen a drive be able to get 30 files in 1 second at the same time. So with the SSDs and the NVMe's, we've noticed tremendous amounts of performance, and it's able to play back stuff that our drives aren't able to do at all. So this is where we went a little nuts with it, and that's with the server that we brought in tonight. So at the end of the year, I get one of these drives. They look a lot like the other ones. They're a little bit bigger. Samsung's making it right now, and by the end of the year, they're going to have 16 terabytes. And if you have 36 of those, which is the front of that unit supports, that's 576 terabytes in a 1 RU space. That produces, like I said, 10 million IOPS. So we're pretty proud of this. And go ahead. It is a standardized connection, and it's new form.
Next generation small form factor, NGSFF.
That's what I said. Yep. So that's the connection that people use. And these, I mean, just one of these alone, like I said, does 3,000, and that's because PCIe 4, it's times 4, is a 3,000 connection. So that's would explain why it maxes out at that.
That one there's 4 terabytes, and it's roughly sells between $2,000 to $3,000, which is very cheap. If you go to buy SSDs, you're going to spend $1,200 for a 960 megabytes. So it's probably megabytes, yeah. Gigabytes. I'm sorry, yeah.
Yeah.
But so it's still very cost effective.
Yep. So not only is it cheaper, but it's actually a lot faster because you're not capped off at that cable.
See, maybe you can tell them the design that it runs on the PCI, and then
sure.
how that motherboard's set up.
So like I said, this laser pointer it's too bright. So this unit and this unit right here, they work together. They're kind of little CPUs, and what they're doing is they're splitting the front backplane of the drives in half, right? And what happens is, if there's a lot of traffic on this side right here, then this controller will actually pick up the work for this one and make sure that the load of the drive is distributed across the back here. So these cables, they go back to the PCI bus, and they directly connect it right into it. So you bypass the whole SATA and SAS connection part. So how do we leverage all this? Because fiber channel is not going to get us there. So in 2010, they have the IEEE stuff that came out, and basically what that is it's the birth of 40 gigabit and 100 gigabit, right? And this gives us a lot more flexibility, meaning that I can have one of those servers and have 2 outputs of 100 gigabit and then put it into either 2 separate switches or put them in both into one switch and do LACP, which is you're bonding it, meaning it's sharing the work together. Or you can go direct connect into the back of the workstation so that you can have pretty much any kind of playback you desire. It does both. You have to have both for that. Oh, yeah. Okay. So the question was, for LACP, do you need to configure that on the switch or on the host? And actually, it's all of it. You have to configure it on the client, so it knows if its client isn't, also doing LACP. The switch has to know which ports are enabled for the LACP, and the server also has to be set up. And there's 4 different modes. We tested all of them. We found the best one is the AC mode, which does both loads maximum output.
Can you explain what LACP is?
Link aggregation, something that starts with a P, protocol. I forgot what the C part was.
So it's putting multiple Ethernet.
Yeah, basically you're taking a bunch of Ethernet cards and you're making it one big one, so that you can have multiple people connecting and that you're not interrupting the connection.
That might be your C.
Maybe. It could be.
Just thinking.
Yeah. Yes.
Maybe this is later, but when I see 40 gig, I'm an Apple person, so I think of Thunderbolt.
Uh-huh.
Does that tie into like editors and that kind of stuff?
You can, sure. Yeah. So Addo came up with a device that will allow you to connect Thunderbolt 3. The 2 will not work because 2 you're capped at 20. So the fastest network you're going to be able to have is going to be 10, because 25 there's no drivers for it yet. So now that Thunderbolt 3 is out, it will do 40 gig, and they actually have a Addo 40 gigabit card that goes 40 gigabit QSFP, which is the connection type, to Thunderbolt. So we're excited to test that out as well.
Yeah, they've just come to the market, and those are
$1,583.
Yeah, about $1,500 for that. And then you need the G-bit cable, but they're not that expensive, but yeah. But that's all you can do, because on a Mac, you're really limited, to 10 gigabit.
C stands for control.
Control, okay.
That makes sense. So I'm going to turn this over to Bill, who has a lot more network experience than I do, so he'll take it from here. Oh, yeah, one more question.
Can you talk a little bit about throughput and latency? Because normally we'll use this in any environment where we have over 100 clients trying to stream high bandwidth content, basic content, and high ops is fine, but as you're getting more clients connecting to the system, what's your performance in terms of streaming for us, and what is the latency?
It's 10 million IOPS. There's not much latency, but yeah, it's a good question. So, how are we going to still deliver high IOPS and high bit rates when you have multiple people connected? Well, we can start with this system. If the protocol calls for it, the job calls for it, we'll have to put the system in, and the system will be able to have a total of 6 100 gigabit outputs that go into and feeds whatever switches you want to. So, if we have 4 NVMEs in here, we can saturate 1 gigabit line. We can saturate a 100 gigabit line. So that's easily 10 clients connection that are at full rate, as fast as it can go. And that's just one of them. We got 5 more to go.
Okay. I tend to be a loud talker, so I don't want to blast everyone out of here. Anyway, I'm Bill Webb. I'm with Mellanox Technologies. Anyone here familiar with Mellanox? Ever heard of us? 1, 2? Okay, awesome. I like it. Quick history. We've been around 19 years. Our history really is in high-performance networking. If you look at the top supercomputers in the world, our InfiniBand networking kind of backs a large majority of those. So we're really, we have a really core engineering team that is focused on high-performance, low-latency networking. In the past 7-8 years, we've taken all that knowledge capability and applied it to Ethernet networking. And in that time, we've grown to well over 3,000 customers, worldwide presence, a lot of different verticals, whether it's cloud, finance, et cetera. And then, media and entertainment is certainly, a huge focus for us. In fact, if you look at it, we have 2 primary areas that we focus on for media and entertainment, really around video streaming and also storage. If you look at it traditionally, video streaming's SDI, now it's making a migration to IP. And then again, storage, fiber channels, sort of declining, and Ethernet is really kind of taking over. So this is just a quick sampling of some of of our customers, as I mentioned, really around streaming and media storage. So, you look at market trends right now in Ethernet networking. As Steve showed, 4 NVMe drives can saturate 100 gig link, right? So, we've seen a huge shift towards, networking of 25 to 100 gigabit per second. This pie chart kind of shows you where the market's going. You look today, about a third of the market is, below 25 gig. 1 gig, 10 gig is sort of your traditional sweet spot for networking. But, over the next couple years, we see 25 gig and up being, a lion's share of the market. What's interesting for Mellanox is for network adapters, we are by far the market leader for speeds 25 gig and up. We have about 75% of the market share for all network adapters, 25 gig and up. So, you look at storage trends in storage network or in storage in general and what it means for the network. You think about it, 20 years ago, the SAN was the king, right? You had the scale-up storage system. It used fiber channel, and it had, there was, primary storage, and that was about it. You look at how things have changed over the past 20 years. The stuff people are storing has changed immensely. I mean, people upload, cat videos to YouTube, right? People post their pictures and share them on Facebook, etc. The needs for storage have just fundamentally changed. Also, the way way stuff is accessed has changed too. So, there's a fundamental shift in, storage systems. In addition, look at market trends for NVMe. If you think about it, Flash has been out for several years, but the whole use of legacy protocols, SCSI-based protocols, really was holding back Flash. So the beauty of NVMe is you can directly access the storage medium over the PCI bus and really exploit the capabilities of the storage medium. And that's exactly what's going on here with Digital Glue's products, which are awesome. Then the problem, sort of becomes, if you can access that storage medium fast, how do you leverage that over the network? So you look at where storage networking has been. As I mentioned, fiber channel, SAN was really the core of what was deployed over the past, 20 years. And you look at it, 20 years ago, I mean, fiber channel, had much better performance, right? It could provide, low latency, high performance, sort of lossless operation. Ethernet couldn't do it. Ethernet was cheaper, but it couldn't provide, the latency and performance needs that fiber channel could. Well, look at it today. The times have changed quite a bit. These days, with an Ethernet network, we can provide the same high-level, low-latency, networking. We can, using some features, do lossless operation, which means, Ethernet traditionally is lossy, meaning that if a queue got full, you'd lose a packet. These days, with Ethernet networking, you can actually prevent that from happening. And actually, the best part is that, I can provide with Ethernet switching 3 times performance. So I can do 100 gig networking versus 32 gig with fiber channel for a third of the price. So at that point, it really becomes, obvious that Ethernet is kind of where the trend is. Also, if you look at the marketplace, there's definitely less Ethernet vendors than there was before, but there's only 2 primary fiber channel vendors. So, you talk about cost, with it being a duopoly, that's also a disadvantage of fiber channel. So what does that mean? So Mellanox is really focused on this concept of Ethernet storage fabrics. So the trick is that, I kind of mentioned traditionally Ethernet really isn't capable of providing the high performance required for storage systems. Well, Mellanox is really focused on providing these high performance, switches for these environments. In addition, one of the key takeaways with working with, Digital Glue is they're going to do some integrations with our switches. That way they can provide, visibility into the network. Instead of, this kind of siloed approach that typically has happened, with Ethernet storage fabrics, you can have, a lot more cohesion between your storage and your network environment. In addition, we have very unique form factors. What's kind of cool here, I like showing these better because I'm amazed about this technology. But this here is actually a full Ethernet switch in half a rack unit. So we make these purposely for storage environments where, you need a handful of ports for your storage nodes, and then you can connect it out to the network supporting your clients. So, this is capable of, actually, the other switch I have is actually 16 ports of 100 gigabits per second. So you think about the high bandwidth that you require in the NVMe-based storage systems. In a half a rack unit, you can get a huge amount of throughput that you require. And then, you look at traditional fiber channel, which had the separate network with a, kind of scale-up storage system, and now there's a big migration to sort of scale-out networks and infrastructure. One of the key takeaways here is that, that network that you're building for everything else, including your compute and workstations and all that, that's now one and the same with a storage network. So that gives you, administrative, you're managing one network, so it saves on administrative costs. You're leveraging the same products between, compute networking and storage networking. So there's a lot of efficiencies to be found when these, when Ethernet storage fabrics become part of your regular network. So, the question is, well, if, Ethernet is great for storage, do I just use any, Ethernet switch? And, being Mellanox, someone who provides, switching solutions, our answer is no. For one thing, speed, you need to be future-proof. If you're looking at, high-performance storage, you need to get switches that, will be ready, today and for the next 3 to 5 years. If you go into the data center, or you go look at the infrastructure that you have today, these NVMe devices have latency, some of them 10 microseconds and less. If you go and look at the switches that you might be using today, their latency might be equal to your storage medium, or if not more. So it makes no sense to invest in this, really, hot storage system and then use legacy equipment where you're not able to exploit, what the storage medium can do. So really, if you're looking at, current and next generation storage platforms, you really need to evaluate the networking that you're using to support it. And this goes back to really what we provide. I already kind of talked about the form factor. Performance-wise, I mentioned our history is in high-performance networking. And really, those capabilities are unique in that we build our own chipset that goes in our switches, which is different than most other switch providers. And in that chipset, we have a lot of these kind of low latency, high performance capabilities. So that's why, we're kind of uniquely positioned in sort of this, NVMe-based storage platforms. Another important aspect of our switches are the support for RoCE. So RoCE stands for RDMA over Converged Ethernet. So on the adapter side, I mentioned that we're market leaders for network adapters for 25 gig and up. If you look at how data is moved in and out of the server, right, you look at what these guys are doing here, there's a lot of boring stuff that can traditionally be done, that is traditionally done by the kernel, right? You think about, okay, I have this data on this server, I have to move this data to this other server. Let me put it through the IP stack, send it to the network adapter, send it across the wire, and that happens on the other side. It goes through the kernel, decapsulates the packet, sends it to the application. There's a lot of CPU time spent doing that, and it's really boring stuff, right? You don't want to spend all this money for CPUs and have it do this stuff. So actually what Rocky does is it allows the network adapter to directly access application memory. And so like, when you want to transfer data from one server to another, you use a special Rocky messenger service where, you tell the network adapter, hey, the memory's ready, here's what I want to move, go do it for me. And then the network system provides an offload for transferring the data. That's going to be more and more a critical technology for a lot of what's going on in storage and a lot of other areas. So just a quick view for Mellanox, we obviously build switches that are really focused at high performance storage networks. We do a full line of Ethernet switching for, any kind of data center. So, another big area for us is cloud networking. If you're doing, shared infrastructure in an enterprise, that's another big focus for us. But, the two switches that we have up here are the bottom two, the 2100 and 2010. Like I said, these are ideal for these type of storage environments we're talking about. Quick note about performance. So Tolly Group is a third-party kind of benchmarking company in the industry. When our latest generation switches came out a couple years ago, they did some tests of our switches versus a couple of our competitors. And they found, in every category, or just about every category that matters for switching, we showed far better performance. So, you look at like the bottom left picture about latency. We can provide consistent 300 nanosecond latency no matter how you use the switch. Even as the packet sizes increase, which is very common in storage environments, we can provide a consistent 300 nanosecond latency. So if you think about it, if you have storage medium that is now in the few, microseconds of latency, that 300 nanosecond latency starts to become really important. Excuse me. Also in the top left, the way internally, if you look at our switch, we have the way that we do our internal buffering is different than most other switches, and that allows us to have much better kind of microburst absorption. So you think about like bursty situations where you're reading data and it's bursty over the network. We have much better absorption for that than others. And then we're full line rate. So that means, some switches have a certain degree of oversubscription. So if you start to, tax it with too much throughput, you start to throw away traffic. Our switches are 100% line rate for all packet sizes.
I have a question.
Yeah.
So if you direct connect versus use a switch,
right,
do those things change? I mean, obviously you're not going to have collision, but if you have, you take your network cards and put them all in a server and direct connect in it, how does that compare with all that, with all those?
So you're talking about like just direct server to server
as
opposed to a switch?
Because in the production situation, a lot of the time you don't have to go back to a server room. You can be right there and direct connect.
Oh, you're talking about direct to connecting that?
No, direct connect between two of your cards.
Then there's one less step, less latency, and one less chance for queuing and bursts and stuff. So I would, in that circumstance, the performance is probably even going to be better, right? Potentially.
Is there a reason not to direct connect?
No, I mean if it's
you have a small amount of clients, obviously.
Yeah, if you have a small amount of clients, I don't see a reason to have to implement a switch to add another stage of latency and stuff. Yeah, I mean I would look at direct connect if on our adapter side, and this is something that we can maybe follow up on later. We have like this idea of host chaining, which is exactly for that, to be able to have a small amount of adapters kind of connected together. So instead of just being two, I think it's like a series. You can connect a few of them together and host chain them. So, and I mentioned Rocky. I mean, this is a technology that's critical for a lot of different high performance kind of applications. Storage being one of them. And so this is. This is really, it's focused on offload, using the network to offload a lot of the work that used to be done on the CPU and then unleash the performance capabilities of the storage medium that you're using. Just a quick note, performance with our switches, we run benchmarks, compare us to, other switches out there. This graph, it's kind of obtuse what it means, but basically, Rocky has a mode where you can tell like the sender to not send traffic. If the network looks like it's going to be congested, it can say, hey, stop sending traffic for a little while. What happens is, that it results in what's called a pause frame. And so if you look on the left side here, the switch that we tested against showed a high number of pause frames, which meant that the switch was showing congestion, was basically showing that it couldn't keep up with the traffic that was going over it. And you compare it to our switches, it was perfectly smooth. It meant that, in the same test, our switch was able to keep up with the throughput and the bursty nature of the traffic.
Is Rocky an open standard, or is that proprietary?
It's open standard. Yep, completely open standard. Yep. So in choosing a switch, in summary, we've already established that, Ethernet is where things are going for high performance storage networking. Fiber channel is declining. But, if you're looking at implementing Ethernet based storage, you really need to look at, what switching you're using. You need switching that has the right form factor, that has the right performance, and is really an end-to-end solution. We at Mellanox can provide an end-to-end network adapter, switch solution to be one throat to choke in these environments. Now, as another note, this is, a little bit adjacent to storage, but I figured, to kind of back up Mellanox's, focus on, using the network to provide offload. We do something similar in video streaming. So, you look at 2110, SMPTE 2110, which is focused, it has the standards about how to, use IP for transporting unencrypted video data. Well, that data is big, right? You look at this table here, it shows, you're talking about actually exceeding the throughput of 100 gigabits per second for one video stream. And, if you look at the standard, it has this concept of packet pacing, where you want to send out all the packets at, a certain interval. Otherwise, the receiver could be overwhelmed. And if you look at these high rates, it's just not possible with a CPU-based solution. So in our adapter hardware, we're actually able to, implement this sort of sub-microsecond packet pacing. And so again, this is, kind of some of the value that we can provide from a hardware, network hardware point of view for video applications. The packet pacing that's 2110 compliant. It does the kernel bypass where, when data is going in and out of the server, the kernel doesn't have to do this sort of boring work. And it's actually aware, it's actually frame aware. So it can do, take packet to frame and notify or copy to the application memory when the whole frame is in place. And that's what I have for Mellanox. So, thanks.
I have a question. Let me ask something here.
Yeah.
It's pretty amazing that you're here. I had a customer call me this morning, and he was looking at a multicast stream coming off of a harmonic, and on one switch, he was looking at the closed caption with VLC, and coming out of one switch, the closed caption was all garbled up.
Mm-hmm.
Then he was sending it to another location.
Yeah.
And the other location, it looked just fine.
Yeah.
So I thought that was rather strange that a switch could cause a problem like that. Is that common?
Yeah, it could be, is it, there's, is there packet loss? Is there jitter, variation in the arrival going out one port or, versus the other?
Well, I told him to see if he had a deck tech, look at it on deck tech, see if all the skids and everything was right. Cause
yeah.
It just sounded strange to me, and all I had to go on was what he was telling me.
Yeah. Yeah, to me, it just sounds like it's either some sort of loss or variance thing in the network, right? If one, or maybe what his output is something wrong with that could be the other difference, right? Did you?
So, do you support SMPTE directing a switch, for example, SMPTE direct or multi-channels?
So SMB Direct, SMB Direct is basically Samba or SIFs with support for Rocky. Yeah, absolutely. That's one of the reasons why we're working with Digital Glue is we provide that type of solution.
So all the performance testing is done.
Yeah.
Is that with SMB or NFS?
So that's a good question. Like the Rocky slide I showed you, I don't know if that's directly with SMB or just a more generic Rocky test, but I certainly can talk to our team and see what benchmarking we have specifically with SMB. I'm sure that we do have some. Yeah.
Okay, so now that we have this storage, really it's about how can we enable creatives to use this and how do we go back to the way we've been doing things and figure out, okay, now that we don't have these limitations, what can we do? So we've been working pretty much with HD technology for a long time. All the 4K workflows we've been doing have really been how do we work within the limitations of these HD systems in order to get 4K working. So as far as the storage goes, it's 1 gigabit Ethernet, 10 gigabit Ethernet. We end up not being able to do image sequences in real time. So VFX is limited to working, frame by frame in these environments, and you have to have specialized systems for these artists to work. So you have the artists doing VFX shots separated from the editors. That can lead to some creative issues with collaborating. And then you have compressed RAW for real time, where they're basically taking the file sizes and making them smaller, but they put more stress on the workstations. And so then you, on the other side, have the workstation limitations, which for that exact reason, people use intermediate and proxy codecs to try to get their systems working in real time. Because that's really the most important thing, is to get the systems working in real time, playback. So when you have a director in the room and they're watching, the screen, they don't see anything dropped, because that's a lot of time, a lot of money lost having that person in the room. So, technology's been moving really fast. We've got, 4K, 8K, where's it going to stop? Well, really, a few years ago, I went to this great talk, I think it was at SMPTE, right before NAB, and a scientist from Dolby basically they had done the studies. They found, okay, what are the limitations? At what point does it not matter that we're innovating anymore? And really, depending on your viewing distance, 2K to 8K, 8K when you're right up against the screen, 2K if you're like in the middle of a movie theater. And the color gamut, which is just, the range of colors that are contained in the image, it doesn't matter if it's past what the human eye can see, who cares? And then 21 stops in dynamic range is the range that we can see with the human eye, but actually within that we can only see 7 stops. So Rec. 709 is pretty good for covering that, but what's actually happening, it's really weird when you learn this, is that if you see outside, okay, I can see everything out there, you look inside, what's actually happening is your brain is doing that difference to make you think you're seeing everything, but you're not actually seeing that other area with as much detail. And then 12-bit is really as far as we can see as a distribution format. So once you get into 16-bit, that's still good for when you're working with the footage, but as something you can visually see, you can't get past 12-bit. And that's pretty much, with OpenEXR 16-bit half flow point going, we can do 3 streams on this box, you pretty much have that covered for an editor working in a session. So what can we do now? We can do end-to-end online workflows, seamless collaboration between the entire post-production team. Because of the caching you can do in here and the SSDs, you can start getting artificial intelligence working on this environment without that interfering with your artists. And we can maybe even get to the point where we're looking at masters as the deliverable format. And then there's also some things at the end which are way, or not as far as we would think, but interesting technology has become available. So for end-to-end online, really it's about you don't have to wait for these transcodes anymore. You can just start working right away. But maybe you do want to convert to something like 16-bit OpenEXR to work like in an ASUS pipeline. There's some benefits to that. And the most important part of it is, right now, when you're doing, let's say, a big feature film, you've got this period at the end, the finishing, where you actually have people looking at what the image actually looks like, what everyone's going to be seeing for all time afterwards. But right now, you just have for that time period. When you start getting end-to-end online workflows, every single person working on it is seeing that the whole time, catching every problem as it happens. And you have non-destructive processing. So you can work with artists together and they can work with metadata formats rather than destructive formats. So people can experiment with doing ASUS transforms embedded in the file rather than baking it in. And so that really goes into the direction that the NLE manufacturers are going, where they're building more collaboration tools. DaVinci Resolve now allows you to work with your editorial, VFX, audio, all in one application, in real time, on the same system. We actually have a DaVinci Resolve database built into all our systems, so you can do this right out the box. And Adobe has, with their dynamic linking, team projects, and just their new project sharing systems, you can do collaboration in there as well. And Avid, of course, has been sharing, and they actually even have a Fusion Connect, so you can do VFX in DaVinci Resolve. So once you have the entire team working off of the storage, in parallel, they're working with the same files. There's a lot of time. I have done work as a colorist as well for a long time, and most of the job is really this conform, relinking, managing all the versions, figuring out what the heck everyone did before you when it gets to you to fix that, because you have to make it look right. And you have to make it, seamless so that if someone's saying comments to you, you can do those things. And so that really is just all gone. You can just work in parallel, all this long, production timeline that is, you do your job and then you do your job. It's all everyone working together in real time. And they even have, like in Resolve, that's a timeline comparison tool. So it literally can see what the differences are in the timeline. You just accept them. So then we get into artificial intelligence, which really we're at the forefront of right now. I mean, it's really interesting. We've had AI-based auto-tagging transcription. Those are kind of, okay, that's, people understand that's the logical direction for it to go in. But now we've got NVIDIA, and actually I've been hearing some other people like Sony and other manufacturers really working on, creating new pixels. Once you get AI understanding something once, it understands it, and you can use it for all kinds of things. And once it understands how light works, how images work, it can figure out logically what would be there with these physics engines. So now you can start creating more bit depth than you actually shot. And now I have not seen anyone actually try that creatively. I actually saw in a forum people were debating whether this actually would work the same way or not. So it'd be interesting to see a test of that. But especially for like up-resing or old content, you can restore it a lot better. And then machine learning for automation really is going to be the area that's going to be most interesting to watch, which is let's just point it at stuff and see what it can learn. And really that's going to get into these tools where these technical processes we have now that require a whole team, you could just do because someone says something with natural language, I want to do this thing, and then it starts working with the artist to figure out what that is. And then we have masters of deliverables, which we already have the IMF format. But can we get to a point where IMF is directly in your application and you just have the project and it goes out and you have one file that can just do everything on the fly? And you can have metadata-driven decode where you have one, whether it's an ACES or some form of HDR or HLG, where you can just dynamically create on the decoder, on the player that the person has their viewing on, actually do all that processing. When it goes to the TV, can the TV adapt and show the right image for that display? And that's really, once we get, fiber right now, but also once we get into 5G and that really starts expanding, a lot of the infrastructure we have right now, we have this pipe, we can go direct. What are we doing? And so really we have this coming, revolution. We've got brain-to-computer interfaces that are going to start coming out. Elon Musk even said that maybe that's coming out in December. They'll have their first device. And this is actually, these images here, this is what right now, or actually Google did this. I guess 2 years ago they did this. But this is what they can, like the first images in each one of these is the actual picture. And then somebody is looking at it. They're looking at that image, and the rest of them is the computer trying to figure out what they're looking at without knowing anything but the data from their brain. And that's getting more and more advanced. So once we get into that, and then also like motor functions, those are really easy for these things to pick up. So, like I was at CES, and they have in the cars, you can do the brain-to-car technology where it knows when you're going to go turn the wheel. It knows faster than you can actually turn the wheel that you're going to turn the wheel. So it starts turning the wheels already for you. Things like that. So how does that work when you're editing and you think, okay, I'm going to go do these 5 steps, and then it already knows you're doing those 5 steps before you even do it. When we get to peer-to-peer streaming where, when you get 5 gig, why are we, doing all this technology in between when you can just go direct out on a box? We have these integrated AI tools, which especially in like virtual reality and these other mediums that are coming out, we have no idea how these can be used. And they'll probably be too complex for people initially to do, but we have this, AI tools to basically help us along the way with that. And, with blockchain asset management, there's something that blockchain's kind of been going back and forth. People don't really understand what it is. But ultimately what it means for, this industry is that when you execute a process, it knows all the steps in the workflow it's going to do. So once it gets to that next server, it already has all of its instructions. It does it. Everyone along the whole pipeline knows what's going on. The person who pays for an ad, they know when it runs. The person who's viewing the content, they know what their data is being used for. Everything is just part of the process. And then, of course, we get into the virtual, augmented, mixed reality. Be interesting to see how augmented reality will be used for these creative tools where you have your screen, but then you have an additional interface around it. And then really spooky, femtophotography. There's a really great TED Talk where they go into this, where they're shooting at the speed of light. So they have 1 trillion frames per second, and they can start to see, the camera creates ripples. So they actually see the way the light goes in, the camera as an observer is actually disrupting it on that level. And they actually have to account for that. But they can see the way the light goes, and because they can see it as a particle, they can actually see it as it shoots, bounces off something, and then bounces back. So they can technically see around corners, depending on what they actually get back from it. So it's really interesting stuff. So, we are barely ready for any of this stuff as it's coming out, and it'll be interesting to see where it goes. Any questions? Yeah. Yeah.
All this shows that makes you resolve and everything, all that stuff, and how much things are changing. Is there any talk about like working with EVF? EVF is the biggest motion replay system, right? And it's the big thing. At the end of the game, you do a game, right? There's always a melt, right? Now say use proprietary right now. It's like,
right.
I want ProRes, whatever it is, boom, output it to a drive, and you walk out of the truck. Is that something that's tying into that too? Are you working with those guys at all?
We are talking to EVS. One of the things that's great is DaVinci Resolve now has an API. So most of the functions that happen within it can be customized like that. So we can now build workflows where, okay, the file's here, now it's on the storage, now put it into a project and do this with it. So that's the stuff we're starting to look into now and adding a lot more functionality to these tools because they're opening up their internal processes outside in development.
You kind of went through them, not maybe everybody knows what ACES is,
oh, yeah.
IMF is.
So yeah, actually, no, that is very important. So the Academy, or how many people are familiar with ACES or have heard of ACES before? Okay, so nobody. So this is the Academy Color Encoding Specification. So basically, the Academy was looking at how are we preserving films, how are these workflows being done throughout post-production on all these films that now at the end of the process, you have film, that's something you could store on a shelf and it was there for future generations, you could restore it. But when you get into digital, everyone had all these different workflows and they didn't always preserve the image. There wasn't clear what is the thing we should save. It's the highest quality. So they looked at the tools that were available. They settled on OpenEXR, which is a format from ILM that has been made open source. And
how big is an OpenEXR, like a 4 or 6K file?
Yeah, so like a 4K file, 4K DCI file would be like 1.3 gigabytes per second. Like each frame is 51 megs. So the real thing too is that the IOPS that it requires to play it, playing 24 of those frames per second. That's why you need servers like this, like the SSDs. We actually have a unit that has 4 NVMe slots on it with the PCIe connection, and the rest is spinning disk. So you can do spinning disk or you can do NVMe for the top 4. So you can use that as a cache. So basically they figured out, rather than using LUTs, which are destructive, which are lookup tables basically, which is the original technology they created for color grading to manipulate or to basically look like film, right? So they take the digital image in, and then they have the LUT on there, which then looks like it goes out to the film. They take that off, they print it to the film, and then it looks the same for the chemical process. And then once they took out the actual printing of film again, they just kept the LUT on there for the look. So ACES uses a transform, which is basically an algorithm, so it's non-destructive. So when you make changes, they can always go back. You can do anything along the pipeline, but it's a standardized system for everyone to work in, and the color space is wider than the human eye can see. It's 22 stops dynamic range, and they have all these transforms that go in from your camera into a common space. You can work with them all the same way, and then out to whatever your display is. So you end up with a master that is the largest container you would need, and then every time a new display comes out, you just put that transform in at the end, and then you can go out. You have your finished product. And in an application like Resolve, it's as easy as just opening up your settings and saying, this is the camera I have as the input. and then this is what I want to go to as my display. And then you just work in it, and it's really smooth. That's what I use when I do color. Like, it's really great. And I think Universal at NAB 2 years ago, maybe 2 or 3 years ago, they said that by 2020, all of their films will be done with this.
What does Fusion connect to DaVinci Resolve?
Yeah, so Fusion, it was a VFX application that was acquired by Blackmagic Design. And then just at this last NAB, they integrated it directly into Resolve. So now you have a complete VFX application within DaVinci Resolve.
And it used to be, I mean, it's $399. It's actually included in it.
Yeah.
So it's all $399, whereas the competing from Autodesk is $10,000, and they limit it to each GPU.
Yeah.
So it's.
So you don't, that doesn't mean that Avid sends.
Yeah, Avid can send shots into DaVinci Resolve to do VFX it, and it's a dynamic connection.
And it can do that right now?
Yes. And it could do it before when Fusion was a separate application, so they just carried that over.
So how do you do that?
Basically what it's doing is it takes the video, it encodes it to like an image sequence format like DPX or OpenEXR, and then you work with it inside of Fusion, and then you choose, okay, I'm going to render it, and it makes a version, and it sends that in the application, and then the connection basically keeps track of these different versions. Now the editor can see, okay, this is the new shot, and automatically gets updated in Avid.
What, all of this is live online. What do you get to when you're carrying it down into the salt mine for archival purposes? What is there that is a transfer, or, I mean, is that even considered in this, or is this all just strictly?
Yeah, so we have, for archive, so the question is, we have the speed for online, but what do we have for archive? We have a unit called Montage, which basically is just scale out. You can get 60 drives in a unit, and we basically use that with S3 protocol from Amazon for object storage, or we also can just do it as normal RAID. So that's our scale out. That's our cheaper system for that.
But that's always considered, you know, online. Is there anything that doesn't require power? I guess that's what I'm looking for.
Oh, got it. I mean, we work at Digital Glue. We work with LTO manufacturers, ODA with Sony. Like, we provide full gamut of solutions.
Put it off to LTO or tapes.
Yeah,
So we have
we'll work with
an
the customer to figure out whatever they need.
Technology that
Exactly.
you can dump it to
It's
when
still
you're.
Yeah.
cost effective for,
Exactly.
yeah. And that's typically people want their content back within 48 hours. So that's kind of the standard. So
I'm just saying you can't have everything online all the time, just the power that it would take to run, to keep something that's not going to be used for.
Right, and exactly, and that's what with Creative Space, I didn't really go into it, but Creative Space is really our platform, which is OpEx instead of CapEx. So you basically pay monthly, you get the storage, you get support included, and you can start now with whatever you need. You don't have to buy for the next 2 years, 10 years, whatever. You just get what you need now, and then you scale it out. And so then basically you have us as consultants to work with you to figure out what your needs are on an ongoing basis. And we have all kinds of analytics that we basically put on systems and can go out to the workstations to keep track of everything that's going on, identify bottlenecks, all that kind of stuff.
So to give you a sense on the nearline, 500 terabyte system kind of in the cloud, you got 3 of them. It's about between what the commitment is, like $12.95 to $16.95 per terabyte a month, whereas on LTO that goes down to $5.95 a month for 1 tape or $6.95 for 2 tapes. So really, if you, yeah, exactly, yeah, and they're disparate, 2 separate tape drive systems, and you could take one and put them in Iron Mountain or whatever. But so it is a big difference. If you say I'm going to just build up petabytes of spinning disk, it gets very expensive.
Yeah.
Millions of.
And I can't say too much about our roadmap right now, what we're doing, but we are working on stuff that helps you keep track of all that and make it simple.
And then typically you also have 3 copies. So if you S3, there's 3 different copies on different systems that are also rated. And they can either be all in the same rack or one on, we have it where people have it one on site, and then we have one in LA and we have one in Atlanta. So you can split them out or have them all in the same rack. But the way that they work, like on the object storage, is you need 3 complete separate systems.
And that's really what we're hoping with this platform, by making it OpEx and working with customers with a continuous dialogue, that we'll really learn what people actually need, what they want. When you pile in features, a lot of them day to day don't get used. It's like a lot of people have media asset management systems. They do all this work to set it up, and then they don't keep it up day to day because nobody's enforcing it. So that's what we're really trying to figure out. Okay, what do people use? What are the tools that will make their lives easier without, adding all this additional functionality that they're not even use.
This, if I remember the specs on this box, they were saying that 32 cards,
36.
36. Each one right now is 4 terabytes.
4 terabytes, yeah.
What's the power draw on something like that? If you're trying to build it into your existing plane?
So it depends. If you have it fully stacked up and ready to go, it requires two 1600-watt power supplies, 220 volts.
Two 1600 watts, but typically that's, you're only drawing at the most 1600. I mean, one could fail. Is that redundant? So this is going to draw 1.5 kilowatt, 1 kilowatt, something like that.
Yeah.
Okay.
At 220, you said, or 220?
Yeah.
That makes sense. I mean,
Because right now we have 120 power drives in there, power supplies, so we can just plug in and demo. But once we get a certain amount of cards in it, or slots occupied, then we have to switch it over.
Yeah.
One of the concerns is people build facilities and they say I can handle 4 kilowatts to a rack or 5 kilowatts, and basically 4 of those would fill up your rack in terms of heat dissipation.
It's 2 terabytes. It's 2 terabytes.
No, it's a tremendous amount.
Yeah.
I'm not knocking that.
Right. So yeah.
Right.
No free lunch.
Yeah. Well, there was a free dinner.
Yeah, there you go. Come by tomorrow. We can have free lunch.
You mentioned two things, Jackie. You mentioned power draw and heat dissipation.
Yeah.
So
Power draw is typically not a problem you have in a facility. Somebody could say, I can always bring in more wire, but I can't bring in more air conditioning easily. So.
Any talk about these being operated in hot environments like some of the new stuff that's talked about?
Yeah, no, it's all the new motherboards and all the standards, so they can run much hotter. But the 1RU, you're going to pull the air off. But even that thing is not too bad. I mean, it does make noise. It doesn't make as much noise as the Switch does. I'm just telling you.
So our switch is actually, one of our switches is 94 watts an hour, and the other one is 64 watts. So,
Is a lot of the power in the card itself, because you said also it's 4 terabytes now and you're looking to go up to 32, is it?
It's going to be, 4 terabytes now. Soon we'll have 8 terabytes, and by the end of the year we should hopefully have 16 terabytes.
8s are out now, I think, and then 16.
Do the cards draw a lot of power, or is that mostly in the CPU and so forth?
Probably in CPU. There's probably not much. Yeah.
Because the cards don't look like they have any heat dissipation, heat fins, things.
They don't like heat. You have to you do.
Well, yeah.
That is a
okay.
problem.
On the cooler side, but with the fans that suck it in and the by the finish of the back plane, as long as your room is 70 degrees.
I was thinking more in terms of if you wanted to go up to the 8, to the 16, or 2 when they become available, you're probably not changing the power draw appreciably.
The technology for the NVMe is it has where they wear out, and that's where the intelligence has to be in the operating system, the write system, the file system, is that you can only write so many times.
Yeah.
So that's versus the
Yeah, that's a really important thing to know about the SSD technology, is that it has a certain number of times it can be written to, and that's really what the life cycle is on it. So that's why we'd always recommend that someone have another tier of storage that they actually are backing the content onto, and they use this really for their active projects. So we don't really see, the reason to get that is to, one, get the performance, but also to scale it out. When you've got a larger team, you need to get the people working collaboratively. And you were asking earlier about how we deliver that performance. A big part of it is the CPUs. And so if we can get 2 CPUs in there, they're connected up to both CPUs are connected up to all the cards, so they can leverage that well to get all that throughput through. That's really what we found when we scaled the CPU. As long as you can handle that speed, then you get it through.
And Intel now has, on their Xeons, they have silver, gold, platinum, bronze. I guess bronze is the lowest. So right now we're using the gold ones in there. And what we also find on the storage is that having multiple cores is not the priority. It's really the core frequency.
Yeah, and that's especially important when people are buying workstations, that really the software right now is not properly utilizing all those cores. So the most important thing is to get a faster processor rather than more cores in your CPU.
But on the cores, they now deal with we just got like an i9 chip and it's like 44 lanes. So that's the whole idea of the PCI is balancing lanes and your slots. So now if you build your computer, it's just like, oh, I just don't pick a slot and stick things in it. They all, especially we're trying to get this maximum throughput. There's a whole art to where the cards go, what lane they're going on, what CPU they're running to, and but each one of the lanes is all separate, so they can, there's no bottlenecking that it can run down versus like a SAS or something where you would end up bottlenecking on the motherboard. So and that's why the graphic cards all run in PCIe's.
It sounds like this architecture is meant for permanent installations, because one of the trends now is editing on location, where you want to have a small subset of this, but you're not, trying to get 220 at the kind of current levels might, be a pacing item. Is there any thought to making this?
Yeah, we have a mobile unit, and we're still working on figuring out new form factors and stuff for that. What's going to be the best unit for the market?
This would be great on a truck. I mean, it's long, but it's thin. The amount of storage you could have, and people.
I would come back and say, if you decide you need something that's got 36 4-terabyte drives, you're not trying to power it with a little Honda.
So where's your single point of failure?
Single point of failure.
There isn't.
So yeah.
Everything's redundant. The power supply.
Yeah, we have two CPUs,
Well, you would
power
put one
supply,
network
RAM.
card in.
Yeah.
But typically.
Yeah, it's true. It's really the networking.
Yeah, you could, again, we'll rate it, so it's all set up on a RAID or Stripe, whatever way you want to do, so you could have a card fail or whatever, a carriage.
Yeah, and it also, how we deploy the storage in terms of how we actually format it is a big part of, what the customer wants in terms of redundancy versus speed, and those trade-offs are always part of the conversation we have with them.
When you talk about RAID, though, that brings up another question. Hard drives, spinning hard drives, have a widely varying failure rate when they'll fail. One of the things they found with SSDs, at least in the early years, I don't know how it is now, is that since they fail after X number of writes and it's pretty reliable when they'll fail, they were creating SSD RAIDs and then finding out, like RAID 5, oh, we have protection. No, 2 or 3 of these failed at the same time, so it's not a protection.
Right.
I know that EMC came up with some very proprietary way of moving things around so that you couldn't have them all fail. Can you address that?
Yeah, I mean, these are things we can do. It always depends on the customer. There could be some additional cost because the prices of the drives are always changing, especially because people are using them for all kinds of applications. So really, to solve that problem, we would go to multiple manufacturers or multiple vendors to get the drives from them. So they'd be in different batches.
I think there's probably monitoring things that we can put on here that'll.
And monitor the number of writes, so you
Yeah, right,
hey,
exactly.
it's going to fail
It's
soon.
intelligent.
Yeah, we have software that pretty much anything that can be tracked is pretty much being tracked.
What is that number? What number IOPS goes through before you start seeing, let's say, a failure of one of the chips or a 10% reduction in the capacity?
I don't have that number off the top of my head. I know it's, yeah.
I'm sorry?
We haven't had a bad chip yet.
Yeah, I don't know what the.
I think it's in more like the tens of thousands per drive.
There's like, all this stuff, even the
That's per
hard
cell
drives
on the
now
drive, not for the
have
drive
5-year
itself.
enterprise warranty. They're helium-filled drives we use. 12-terabyte helium-filled. Spinning disk, yeah, and they've got, 5-year warranty. So the mean time between failure on all these things now are just.
Well, and that's the most important thing with the way that we're doing this platform is that it's as long as it's under warranty, we replace everything. So if a drive goes bad, you just get another one. You're not paying for that.
So when does a drive go bad? Is it
It's really the
is
cells.
it an analog decay or is it?
The cells go bad.
File system does a verify on write.
Yeah.
So if you had, other than beyond your rate, but if you had bad sector, it verifies it writes, it can't do it, it writes to another sector, then it goes back and software tries to fix whatever was there and make it available again. So it has a verify on
So the
write.
chips are gonna sort of decay, they're gonna have bits that go bad at some point.
Exactly.
This was just got so much wrong with it that we're.
Exactly, yeah.
The technology is MLC, which is a multi-layered chip. So when the cells actually start to go bad, they're like bad sectors. You'll just get a bunch of, I can't write here, well, I can write to here and it will write to there.
Not like a drive when the motor goes out.
Yeah, when the motor's done.
Right, exactly.
Yeah.
Now,
Yeah.
you can overheat or spike from whatever, and you can, of course, destroy an entire chip,
that makes sense.
but the likelihood of that is a lot less. But burning out that cell by constantly writing and deleting to it, that's what wears it out the most. So
Yeah.
with the new way of writing to the NVMe, it writes to different ones sporadically. So it's never writing to the same one constantly and burning it out. That's how it happens.
We had a presentation once, somebody talked about these chips, and they come in different styles. Your cell phone has got a chip with higher density, but it can't write nearly as much because you don't save new phone numbers that often. These can save more.
And that's even on what we find on our storage, especially when we're doing these workflows, is the write is not the important factor, it's the read. So we're constantly adjusting the system to get the reads, because that's what somebody wants to do is, again, to pull from that storage these files, run real time onto their screen to do it. So it's less important. I mean, the writes are important when you're moving things around, but these things are so fast. I mean, to give you a sense, I mean, we're getting 3.5 gigabytes per second or more on our storage systems, whereas like I've got the latest Western Digital SD card, which is their fastest little terabyte system. Plug in Thunderbolt 3, and you run a speed test on that, and that's getting about 450 megabytes. So these things are, we're getting almost 9 or 10 times throughput there versus a direct connect USB drive on your thing. So it's fast. You grab gigabyte files and copy over, and it's just like,
And that's pretty much where we've been, is we've been using the protocols and the literal storage technology from hard drives to we're just shoving SSD into that. And so that's, the reason why those are so cheap is because that same chip is inside a drive form factor just so it can fit, in another unit. And that costs extra money to put that extra metal around that.
But the problem on all these systems as we test is there's a weakest link somewhere. So you can, if you've got CPU that doesn't have, a fast refresh rate or frequency, that can be your bottleneck. It could be the network card. You can have the fastest storage for whatever, but, or SMB, which the way actually the protocol, that's the biggest thing, we've got SMB3, but we have limits there, and it just kills the CPU on the server. And we've got two companies we're dealing with that have rewritten SMB to get faster speeds and or trying to multi-thread versus a single thread. So it all sounds, great how fast all this stuff is, these fast cards, but when you actually get it on a real life system and start working with it, the bottlenecks that you find.
Yeah, we pretty much pushed the hardware as far as it can go on its own. So now we have to go into that software, the protocols, which we're not really in control of, to try to figure out how to do it faster.
Pin down SMB direct on the card.
Yeah.
And not having the problem just doing all processing.
Right.
It's going to be a lot faster.
Right, yeah.
Multi-channel, get a lot of performance out of that.
Yep. So that's what we have in our offices. We have offices here off of Howell Mill Road, and it's kind of our workflow laboratory. So we have this and other storage set up. We have DaVinci stations. We have all kinds of toys, Nooks, all the different things, and really we just, are testing all the time. We have, people contact us and they've got a specific workflow and they're saying, can we achieve this need? We have right now one we've been working with for 2.5 weeks for a huge operator, and they want to, what are they trying to do? They're trying to get
Sony XOCN working. And that's what we found a lot of time when it comes to having these conversations with customers. It's not so much about the storage or how we're tweaking it. It's about understanding the codecs they're using, because each of the applications has a bunch of codecs in it, and they're all use different resources. And so that's why we try to extend out, especially with digital glue services, into the workstations and these other components of the workflow, so we can figure out, okay, how is your specific application and the codec you're using, all this stuff, utilizing these resources, and how do we optimize that? Because most of the time, the point of failure or the bottleneck is the workstation and being able to process the data we're giving to it. And it's not just, can I handle the speed? It's, can I handle the CPU load this is going to give me? Do I have enough RAM, to fill out enough of to preload enough of the storage? Things like that.
And that's the Sony one. On this one we're working on, it's the Sony uncompressed format, and they want to have 4 layers of it. So they want 4 files to read off, and it's 4K content, uncompressed, and then be able to see it on screen with all the layers running, real time, full resolution. And we just keep, it's what, 23.98, and we're just like at 22.
Literally jumps between
Visually,
22
we're
and
almost there, but it's just getting it to just play straight, and it's just like, okay, where's the bottleneck? Is it that?
Frame rate, it still shows red. It shows 23,976, and I'm like, but why is it red?
So your device is hot swappable.
Yes, they're hot swappable.
How do you custom multiple units? Is it software driven or hardware?
It's software. And you can do it one or two ways. Either you can do it stripes, so that both systems are independent, but they are both up at the same amount of size, or you can do a one-for-one, meaning that they both have the same information at the same time. So if server A goes down, you're on the same virtual IP. No one knows. It just starts to go to server B.
Yeah, and because it's software defined, one of the workflows that we're really excited about is that, especially with a spinning disk, you can create separate pools, and then you can copy to those, and then let's say you're working with a bunch of VFX vendors. You take your content, you copy it to a bunch of pools, you send those drives to those vendors, they put them directly in their storage, and now they're just working immediately, and there's no cloud transfer fees.
And that's the drives we have. You can put them back in the system out of order.
Yeah, it doesn't
have
matter.
everything all matched out. Our ones can go out of order. You can have your standard unit. You can have an extra chassis on it that has open slots. Put 4 12 terabyte drives in there. Copy your content. Pull those drives out. Ship it to another one of our systems. Plug the drives in. Auto discover it. Copy those files over.
And is that handled by metadata files that you are managing it? And when you swap out these drives, you put them into your own system. Your own system's going to recognize those drives and that media content?
Yes, because the rate is actually stamped on the drive and not on the system.
Yeah, the software that we're putting together to do that is going to be released Q1 of next year.
144 terabytes, and you want to gang them together, you're really getting aggressive. You've got some big needs if you need to gang together the 144 terabytes.
Yeah. Mm-hmm.
Do we have the video display or not? No.
I don't think we have audio connected up, so.
No.
Yeah.
Thank you.
Oh.
Hey, Nick, let me ask you something. I know it's late, but let me take us back to the beginning of the session.
Mm-hmm.
Can you clarify for me, when you're comparing fiber channel to Ethernet, is that fiber channel over copper or something like MT fiber?
Is it single or multimode?
Is it single mode, multi-mode, or is it copper?
Fiber channel, for a.
I'm sorry, start it again, please.
It's multi-mode fiber LC.
Okay.
It's 4 gigabit. That we
Single
were
mode,
comparing
right?
to, and we're comparing it also with the 32 gigabit. So that would give you a total speed of 3,200 megs, and our 40 gigabit adapter beats it faster than that.
But you're working on multi-mode, not single mode, right?
Multi-mode.
All right. Oh.
Yes. Back to what you were saying about preserving the films.
Yes.
Is that voluntary or is that mandatory?
Oh, it's completely voluntary.
That's what I thought.
Yeah.
So some studios will adopt it and others will take their time and maybe never.
Right, exactly. Well, and Netflix has been one of the big proponents of it as well.
Well, that's good because they're creating a lot of their own.
Yeah.
Those are whatever.
All right. Thank you very much.